Hello guys, it's Miss Huser on 8 Silver, and I'm going to be going over lesson 7 with you guys. So we're going to be talking about solutions. Some have all solutions, only certain numbers work, and sometimes there's just no solution. So we're going to be going over some examples like that. Alright, so on this first one it says which one doesn't belong. So let's look here and see what it says. So 5 plus 7 equals 7 plus 5. Well, that's going to equal the same. So both of those are going to equal 12. So that one is a true statement. Okay? Let's look at the next one. So 5 times 7 equals 7 times 5. Same kind of situation as up above. They both equal the same thing. So that is a true statement there. Alright, so now this says 2 equals 7 minus 5. Well, 7 minus 5 does equal 2. So this one marks off as well. Alright, now this last one, 5 minus 7, that would equal a negative 2. And then 7 minus 5, well, we know that from up above here, that equals a positive 2. Now, does negative 2 equal positive 2? No. So 4 does not belong there. All of these were true statements except number 4. Alright, so now down here it says thinking about solutions. So we're going to sort these equations in two types. True for all values or true for no values. So let's go ahead and create a table down here. So true, not true. Alright, so if we were to plug in any random number and for that missing variable, we need to see if it would be a true statement or not. Okay, or if both sides of the equal sign are equal is what we're trying to figure out here. So this first one here, n equals n. Well, that is a true statement. We could plug in 20 for n, and 20 does equal 20. So n equals n is a true statement there. So true for all values. Alright, this next one. 2t plus 6 equals 2 parentheses t plus 3. Well, let's go ahead and distribute this 2 to see if these would then be equal on both sides. So 2 times t is 2t, and then 6 times, I said the answer. 2 times 3 equals 6. Now both sides of my equal sign are the exact same. So because of that, we know that all values would be true. So we're going to go ahead and write 2t plus 6 equals 2 parentheses t plus 3. Alright, now to that third one. Let's go ahead and handle this as the problem up above. So to see if these are actually equal, let's distribute that 3. So 3 times n is 3n, and 3 times 1 is 3. Now, the 3n is the same on both sides, but this has plus 3 and that has plus 1. So this would not be true. So this would be true for no values. So 3 parentheses n plus 1 equals 3n plus 1. So if I were to plug in 2 for n, it would never end up being equal. So that's why it's not true for any of the values. Alright, let's look here. Let's distribute that 1/4. So, what you can think in your head is either 1/4 times each of those, or you can think of each of these numbers in the parentheses divided by 4. So 20 divided by 4 gives me 5d, and then 4 divided by 4 is 1, and that does not equal 5d. We had that plus 1 here. So it's always going to be off by 1, no matter what we plug in. So this would be not true. Very close, but not quite. Alright, now let's look up here. So we have 5 minus 9 plus 3x equals negative 10 plus 6 plus 3x. So what we need to do first here is let's simplify by combining like terms. So right here I have two numbers on both sides that do not have a variable next to it. So that means I can combine those. So 5 minus 9 would give me a negative 4 plus 3x on the left. Now negative 10 plus 6 would then give me a negative 4 plus 3x on the right. Now those are equal, so since they are equal, we know that this would be true for all values. So I plug in any kind of number, and I'd always get the same on both sides. So 5 minus 9 plus 3x equals negative 10 plus 6 plus 3x. There we go. Alright, now down here, we have 1/2 plus x equals 1/3 plus x. Well, 1/2 and 1/3 are not equivalent, so nothing else we can really do there. So this, since 1/2 and 1/3 are not the same, this would then not be true. Alright, almost there. So down here we have y times negative 6 times negative 3. So these are like terms. And then over here we have 2 times y times 9. 2 and 9 are like terms. So let's combine those and simplify to see if it helps us realize if these are equal or not. So a negative 6 times a negative 3 gives us a positive 18. So we'd have y times 18 equals, what's 2 times 9? Well, that's a positive 18 as well. So y times 18. Now those are the same on both sides, so we know that this would be true. Alright, so we're just looking to see if they are equal, because that means they're balanced and it's going to always be true. Now this last one here, we have v plus 2 equals v minus 2. Well, those are not the same. It would either have to be both plus 2 or both minus 2. Alright, so that one is not balanced. Alright, now let's look down here. It says write the other side of this equation so that this equation is true for all values of u. So we're not going to completely copy that because that's too easy. So we need to write something that is equivalent on the right here. So the first thing we could do is just distribute that 6 into the parentheses. So if we do that, we end up with 6u minus 12 plus 2. Now that would then be equivalent. The only thing I did was distribute, so I started to simplify it, but these are still the same. You maybe could have taken this one step further and wrote 6u minus 10. So I just combined those like terms there and got negative 10. So, up to you on that one. Either one of those are good, and you probably could think of some other options that are equivalent as well. Alright, so this says write the other side of this equation so that it is true for no values of u. So now we just need to make sure that these are not equal on both sides. So we could just write 6 parentheses u plus 2 plus 2. Or you could have wrote, honestly, anything that's just not the same as what's on the left. Okay? Alright, now onto this one. So they've kind of given us something and we just need to finish it off to make sure that it is true. Alright, so this first one, they have 3x plus 6 and now they have 3 parentheses x plus blank. Well, if we were to distribute this 3, we'd get 3x, which is true over here. So what do I need to multiply by 3 to end up with 6? 3 times what equals 6? Well, 3 times 2 equals 6. Alright. So now we need to look here. We have x minus 2. Well, right here we have it to distribute a negative sign. So if we distribute this negative sign, I know I need to have a 2 here because that's all that's missing. Now I need to think, does this need to be positive or negative? Well, my 2 on the left is a negative 2, so if I distribute that negative, I would end up with a negative 2 there, which is good. And then if I distribute the negative 1 to the negative x, I end up with a positive x, which is a positive x over on the left. Alright, so that one works out well for us there. Alright, now this one. Let's simplify the left to kind of help us out here because it's no longer a fraction. So let's see what we can do here. So we're going to divide both numbers by 5 there. Okay, that kind of just ruined it, but there we go. So 15x divided by 5 gives me a 3x, and then negative 10 divided by 5 gives me a negative 2. So I need to make the right side look just like this. Well, I have that minus 2, so I just need a 3x now. Alright, now if you need to go back over any of those, feel free to rewind the video. Alright, now it says complete each equation so that it is true for no values of x. So, for this one, I just can't, it cannot be a positive 2, so I could put a 1 here. Because if I distribute it, I would get with 3x plus 3. That is not the same as on the left. Alright, over here, I just cannot plug in a positive 2. So what I could do is a positive 3. Okay, so as long as you are not putting the only thing that works, okay? Alright, now over here, this needed to be a 3x. Well, I could write 7x, because I know that that would not be equal to what is on the left. Alright, last part here, guys. So it says describe how you know whether an equation will be true for all values of x or true for no values of x. Well, when it is all true, we would have equivalent expressions on both sides of the equal sign. So, equivalent expressions on each side of the equal sign. Alright, so for example, we could have 3x plus 1 equals 3x plus 1. They are equivalent, or let's do a better example. We could do 2 parentheses x plus 1 equals 2x plus 2. They look different, but they are ultimately equal. Alright, now when it's not true, well, they are not equivalent expressions on each side, so not equivalent expressions. Sorry, my handwriting is not good right now, so I apologize. On each side of the equal sign. So, for example, I could have x plus 2 equals 2x plus 1. Those are not the same. They are not equivalent. There's nothing I could do to make them the same there. Alright, so that is, I'm pretty sure, it. Yep, so go ahead and do the practice problems for lesson 7. And if you have any questions, don't hesitate to reach out to your teacher. Have a good one.